So the last problem that we are going to get the solution for is the HCN. So let's start by identifying how many valence electrons we have. So there's hydrogen, there's carbon in this one, and there's nitrogen in this one as well. Now I know that there is one hydrogen times one valence electron. So that's one valence electron. There's one carbon times 4 valence electrons, and one nitrogen times 5 valence electrons. 4 and 5 is 9, plus 1 is 10 total valence electrons. Now, I know that the central atom is going to be carbon because even though like the checklist that we went through in the notes said that usually the first one is the central atom, and in this case, hydrogen is the first one, but the other checklist rule was that if carbon is present, chances are it's the central atom. So in this case, carbon is going to be my central atom. So to my central atom, I'm going to bond my hydrogen and I'm going to bond my nitrogen. I'm going to start with single bonds. And of the 10, I've used 2, 4. So I have 6 valence electrons to find a home for. I'm going to start by adding my electrons as pairs. So 1, 2, 3, 4, 5, 6. And we have to remember that hydrogen is sort of special. Hydrogen only needs 2 valence electrons. So therefore, if you see hydrogen with a dash, it already has its 2 electrons, so it can't take any more. So hydrogen is actually good as it is. The nitrogen has 6 dots and 1 dash, so that adds up to 8, so that one's good. But the carbon only has 2 dashes, so it only has 4, and it's short. So that tells me that we need to have a multiple bond. So I'm going to grab a pair of electrons and create a multiple bond here. So that would look something like this. And we'd be left with that. So now nitrogen still has 8 valence electrons, 2 dashes, 4 dots. Carbon has 6 valence electrons with 3 dashes, and hydrogen has 2 valence electrons, which is what it wants. So hydrogen and nitrogen are satisfied, but carbon is not. So we're going to fix that by making a third multiple bond, and we're going to do that by taking those electrons from nitrogen and making a bond there. So now I'm going to have hydrogen, carbon, nitrogen. Going to start with my single bond. Going to add my 1 multiple bond. Going to add the remaining electrons, and that. Okay. So now my nitrogen has 8 valence electrons. It has 2 dots and 3 dashes, so that adds up to 8. Carbon has 4 dashes, so that adds up to 8. And hydrogen has 1 dash, so that adds up to 2. And so each atom has the correct amount of valence electrons. The last thing we have to do is identify polarity. So we're going to be looking at the relationship between carbon and hydrogen. So if I jump over here to the periodic table, I'm going to see that carbon is a 2.5 and hydrogen is a 2.1. So let's see, 2.5, hydrogen is a 2.1. So that adds up to a 0.4, which means it's non-polar covalent. And for non-polar covalent, we don't have to draw dipole arrows or partial charges. So we're done with that part of this structure. So then we need to look at the electronegativity difference between carbon and nitrogen. So I've got carbon and I've got nitrogen. And we're going to look and see that carbon is 2.5 and nitrogen is 3.0. So carbon we said was 2.5, nitrogen is 3.0. I'm going to subtract those two and see that it's 0.5, which tells me that it is it is polar. So if it's polar, we're going to have to draw the dipole arrow, and we always draw the dipole arrow toward the more electronegative element. So that would look like this on my structure. When we add the partial charges, we always add the delta negative on the more electronegative element and the delta positive on the less electronegative element. So this would be delta negative, and the carbon would be delta positive, and that's it. So that's the structure. And that's the structure for HCN. We didn't ask you to name this one because it's a little bit more complicated than what we've asked you to name so far for covalent compounds. So hopefully that helped if you had questions about this particular one. But otherwise, good luck finishing the worksheet.